Hello and welcome to Lesson 13, Part D in the online Terrestrial Navigation course. This is the fourth and final lesson on how to use the tide tables. As always, there's a link to a worksheet in the description of the video. You can download it and follow along with. Also, as in the previous three lessons, you'll need a copy of the 1983 tide tables to work through these problems. I have a PDF copy available for download on my Pateron page, where any membership level gets you access to any of the reference material that I have. Or if you prefer an actual book, I got mine from Marine Education Textbooks in Houma, Louisiana for about $50. You can look them up online and call them or order it online, and you'll get the exact same book that you get in the exam room. Okay, if you haven't already completed lessons 13, A, B, and C, I'd strongly suggest going back and doing those before attempting this one. Alright, so let's take a look at today's lesson. Okay, so if we take a look at question 1 here, question wants to know, tells you you're sailing from Elizabethport, New Jersey on 22 May 1983 with a maximum draft of 28 feet. You'll pass over an obstruction in the channel near Sandy Hook that has a depth of 26.5 feet. The steaming time from Elizabethport to the obstruction is 1 hour and 40 minutes. The question wants to know what is the earliest time, zone description +4, you can sail on the afternoon of 22 May and pass over the obstruction with 2 feet of clearance. Now these questions look kind of difficult to begin with, but if you go into it and get the pertinent information out in the order that you need it, you'll see that it's actually pretty simple. So let's go in here and find the first thing we need to know is how much water do we need. Well, the question tells us we have a draft of 28 feet and we want 2 feet of clearance, so that gives us 30 feet that we need, 30 feet of water. Alright, and then how much water do we have? Well, the question tells us we have a charted depth of 26.5 feet. So we need the tide to be 3.5 feet. Alright, so that should start to look familiar here. And then the next question we need to ask ourselves is, when do we need that 3.5 feet? Well, the question tells us we need it the earliest time on the afternoon of 22 May. Alright, now that we have that, we can start our scratch paper here, and this should look real familiar. One of the things you can look at in the problem is it tells you you're sailing from Elizabethport, New Jersey, but the obstruction is at Sandy Hook. So at first glance you may try to get that Elizabethport, New Jersey tide, but the obstruction is near Sandy Hook, so that's where we're going to go. So let's go to the tide table there and get our index number for Sandy Hook. Let's see, where are we at? Right here, Sandy Hook. The index number is 1625. Alright, so let's put that on our scratch paper the same way we did in the other lessons. We'll put our index number as 1625. Then go back to the tide table. And we'll find 1625 in table 2. It's going to be page 91 if you're using the PDF version. And we're looking for that 1625 here. Notice Sandy Hook is a primary station, so there's no subordinate corrections here. So we have no corrections for the subordinate station, and Sandy Hook is the primary station starting on page 64. So we'll put that on our scratch paper. No secondary corrections. And the primary station is Sandy Hook, page 64. Okay, so let's go take a look at our primary station, Sandy Hook, that starts on page 64 in the table. If you're using the PDF, that 22 March date is on page 52 of the PDF. So we're looking at 22 March right here. Now remember, the problem wants to know the earliest time on the afternoon of 22 March. So we've got a low water right here at 10:22, and we've got a high water at 16:41. So our time is going to fall between these two tides right here. So we'll take those numbers and put them on our scratch paper. Do our arithmetic, and then the next thing we're going to check is our zone description. This problem we have a ZD plus 4, so we'll apply that correction to our times, and we come up with 1741 for high water and 1122 for low water. And let's go ahead and get our duration and our range of the tide. Alright, and just like in the previous lesson, we've got the we need the height of tide to be 3.5 feet. So we're going to look for the closest tide, which in this case is going to be 5.1. So we'll take that 3.5 feet and that 5.1, do our arithmetic, and now we've got 1.6 feet to that 1741 high water. And just like in the last lesson, we're going to go to table 3, which in the PDF is page 110. And we're going to enter the table down here at the bottom with our range. And our range on this problem is 5.4 feet. So we can round it to that 5.5 feet right here. And we're going to scroll across until we find that 1.6 foot correction right here. And our duration is 619, so we can round that to 620. And we're going to go up this column till we get to that 620 line in the top part of the table, which is right here. And we get that correction of 2 hours and 19 minutes. Alright, since our low water was at 11:22 and our high water was at 17:41, our time has to fall between those two times. So we're going to subtract that correction from 17:41, because if we added it, that would put it outside of our time frame. And we get 15:22. Now right here you may think you're finished, but if you look back at the problem, we have a sailing time of 1 hour and 40 minutes, so we can actually leave an hour and 40 minutes before this time here. That 15:22 is the time that the tide will be 3.5 feet high, but we can leave an hour and 40 minutes before then. So we'll subtract that hour and 40 minutes from 15:22. We come up with 13:42, which is answer D, and that will be the correct one. Now throughout this exercise, you'll notice that a lot of the problems look a lot alike, and you'll think to yourself, wait a minute, I just worked this problem. But if you read through the problem carefully, you'll see it may have a different date, or you may have a different draft, or the obstruction may be at a different charted depth, but they're all different. There are some that are a lot alike, but they're all different enough to give you a different answer at the end. Alright, so go ahead and grab that worksheet, work through it. If you have any questions, leave them for me in the comments. I'm going to go ahead and get started on that next lesson for the tidal current tables. Alright, thanks a lot.